Hello, this is Group 24, and we are the Intelligent Autonomous Drone Aid Delivery System with minimal human intervention. My name is Ramon Ponce, and I will be taking us over the project goals. So, the project's goal was to develop a semi-autonomous drone that could deliver medical aid to people in need or be used in search and rescue missions or just everyday emergency response situations. The project consists of one drone for reconnaissance and delivery, and it will essentially take off autonomously, go into an area, search for people, and then at that point, with the minimal human intervention, would need to kick in, and someone would need to then deliver the aid or payload successfully, and then also fly the drone back to the home base system. The home base system has the AI on it, so it would take the camera feed into the home base. It would then run through and overlay the box that detects humans, and then from there on, it would display it to the human controller so that he knows, hey, there's a human here. Here's where to deliver aid.
Hi, my name is Ian Blankenship, and I will walk us through the project requirements and constraints that we faced during development. So, to maximize the budget we were provided, we decided to go with a fixed wing drone that was both more efficient and had longer range than its quadcopter counterpart. Moreover, this design of a fixed wing drone led to longer building time and testing time. Um, and because of the time frame, we decided to focus our efforts on one drone rather than three.
So below is a picture of the CAD model of the final version of the fixed wing drone. It was made in Onshape. We collaborated with the members of our team that knew their way around CAD. While there are some parts missing, there are other files where we focused on just that part because it went through several designs. The tail actually has three different designs because over time we refined it. Every part is very important. And you can see we were trying to find the payload, like where to center it, how to like set up the wings, and basically like there was a constant cycle between building and redesign, building, redesign, building, redesign. Um, and so this is more or less the final version, even though there's a lot of changes overall.
Hi, I'm Kenneth. And for our team's AI model, it went through 4 iterations. In the first iteration, we simply refined the convolutional neural network on human detection. On the second iteration, we implemented GhostNet modules, which allows the convolutional neural network to take less parameters but get the same performance, and, and implemented Gaussian filtering to smooth the background out and have the neural network focus more on human detection. Our third iteration, we use walkboard analysis to help introduce more data sets into the training of the convolutional neural network. And on the fourth iteration, we switched to a larger neural network and implemented all the previous features so that this was partly due to not getting our hands on a Jetson board and having the home base run on a PC with a more powerful graphics card. Here we have the demo of the AI model.
Hi, my name is Sebastian Valenzuela, and I'll be discussing project implementation and project testing. Um, Over time, the drone went through three major design iterations. Mainly, the drone just became larger in wingspan as we realized we needed more lift for the payload. After attempting to test the drone at Markham Park, we spoke to some of the locals, and they gave us design tips, and we used those tips to add struts to the wings to improve rigidity. However, this ended up not being enough, and we should have reinforced the center for future flight. Moving on to project testing. Majority of the subsystems went through testing in between stages. The servos were tested using an Arduino to check their functionality and the range of motion. An upgrade to the radio system was attempted by putting the remote into DFU mode and uploading new firmware onto it. However, this ultimately failed and the changes had to be rolled back. After testing the controller, there was signal overlap and the controller no longer worked properly. When the first test flight happened, the underway switch failed and had to be removed.
So while the drone ended up taking a lot more time than we thought and ended up failing in the first test flight, it wasn't a complete failure because it took off, got a lot of altitude before it finally crashed. What it was is the wing loading was too high, so the center was not strong enough to handle it, and so it basically crumpled that interior section, causing it to crash. If we didn't have the payload, we can remake one pretty quickly. And as a group, we kind of plan to like continue and keep working and refining. We worked a lot with the fixed wings. We have a much better idea of how to do it. We have a much better idea of the manufacturing process involved and the do's and don'ts. And we're much more confident in our next iteration.
Lost the wheel, but it's up in the. Oh my god. Almost no elevator.
This is the aftermath of the crash. As you can see, the wings are in one solid piece, but the center is completely crumpled and the rest of the plane is absolutely destroyed.